Okay, in this lesson, we're just going to go a little bit further into the 4.3, or into exponential functions and taking the derivatives. So you already know this, that when we take a derivative, we with an e, we write what we see, and then we multiply that by the derivative of the function. Okay, so you write what you see, same thing as here, and then take the derivative of the exponent of the function. This is very similar to something like this, to doing a u substitution, if you like. So it means the same thing. So let's do an example. So take the derivative with respect to x of e to the 12x squared. Okay, so that derivative is going to be e to the 12x squared times the derivative of the exponent. So that's going to be times 24x. Now you want to put the 24x in front and not keep it behind. So that is the best form for your answer. Okay? All right, so let's continue. So we have this problem down here, and they want us to differentiate this function. So let me just look at this for a second. So yeah, that's your f of x function. So f prime of x, well, do I want to get right to work is the question. And the answer is no. Why don't we first clean this up? Okay, so what is that? That is e to the negative 3x plus e to the 6x times e to the negative 3x. Okay, so what does that make that? That makes that e to the negative 3x plus e to the positive 3x. So you see that? So now instead of writing my function, my derivative, I'm going to rewrite my function. So let's just call this f of x, and it's going to be, parentheses, e to the negative 3x plus e to the positive 3x raised to the 12th power. So therefore, the derivative is going to be 12 times e to the negative 3x plus e to the 3x. Now take the derivative of the inside. So that's going to be negative 3 e to the negative 3x plus 3 e to the 3x. Okay, so can we make this look prettier? And of course we can. Okay, let's take the 3's up in the front. So that's going to be 36. Let's move this up as well. So I have negative e negative to the negative 3x plus e to the 3x, and then times e to the negative 3x plus e to the 3x. Okay? So, and I'm so sorry. This is raised to the 11th power. This is raised to the 11th power. Okay? And that's the best form for your answer. Okay, so let's go on to the next page. So the next page has a few more problems. We're taking the derivative of these. So let's get to work. So y prime is going to be, with e, write what you see, and then multiply by the derivative of the exponent, and then clean this up. So this is 15e to the 5x. Okay, let's do b. Y prime equals, okay, write what you see, and then take the derivative with respect to the exponent. Clean it up. So bring the k up, and that is your derivative. Okay, the last one, write what you see, and then multiply that by k. So y prime equals c times k times e to the kx. Okay? So they're not too terrible. Okay, now let's move on to trig, because I know you've been dying for this. So to do trig, derivative of sine is cosine of the angle, take the derivative of the angle, and that's going to be 21 e to the 3x. Okay, rewrite that with the 21 e to the 3x in front, times cosine 7 e to the 3x, and we're done. That is your f prime of x. Okay, the next one is cosecant. So g prime of x equals the derivative of cosecant is negative cosecant, so negative cosecant times the same angle. Okay, I'm going to run out of room here. Times cotan, the same angle, times the derivative of the angle. And the derivative of the angle is going to be 5e to the 5x plus 2. Okay, so to write this nicer, and I should have changed colors for you, but we'll just put a line like this. G prime of x equaled 5e to the 5x plus 2. Let's make that negative, so then we can not have to have the negative inside here. e5x plus 2x, and then all of that times cotan to the e5x plus 2x. Done. Okay, one more, we can call it a day. Okay, h prime of x equals, okay, left, so I have sine 5ex, d right, secant squared 4e2x times the derivative of the angle, and that's going to be 8e2x. Okay, so that's left d right, plus, and I'm going to write this down here, plus right, so that's going to be tan of 4e2x, d left, so that's cosine of 5e to the x times 5e to the x. Okay, so let's look at that. Do I have anything in common? I really don't have anything major in common, but I'm going to pull out the e to the x and just see if we can write this on one line then. So let me have an e to the x in common. Then I'm going to have, I still need another e to the x times 8. And then I'm going to have sine 5e to the x secant squared 4e to the 2x plus, okay, I pulled out an e to the x, means I have a 5 still, and then I'm going to say tan 4e to the 2x and cosine 5e to the x. We did it. Okay, and I'm going to put that in a box. Okay, done. So that's that derivative. So bottom line, you take trig derivatives just like we always have. When you take the derivative of the angle, remember your rules with exponential functions and follow suit with how you would take the derivative of the angle. Okay, so that's it.